all the teachers and the students, please note we will start the session in another 2 to 3 minutes. Meanwhile, teachers, please ensure that you're on mute and unmute only if there is some kind of an interaction with the resource person that is required. Otherwise, please keep yourself muted throughout the session. Thank you.
पीपीटी कहाँ जाएंगे? ये वाला तो ये दिखेगा ऐसे
दिख रहा है एक बार टैब जो भी इससे जाओ क्रोम सिलेक्टेड है तो वो दिखेगा.
ओके
फ्रंट सिलेक्टेड है तो आप दिखेगा.
ओके और इसको मेरे को चेंज करना है
म्यूट म्यूट इधर से म्यूट करिए.
अरे मेरा फ़ोन बंद कर रहा है.
Sorry for the interruption, sir, but there is a weekend session. Afterwards, there is a quiz also. Then
Shall we begin?
Yeah.
Okay.
Zoom पे जाना है. If you want to see them.
We are live, right?
Yes. I think we are live.
Hello, good afternoon, everyone. Welcome back to the Sparkle series brought to you by Vigyan Jyoti program. Today is the first session of the Sparkle series, and we're going to have an exciting and mind-boggling session around candles and combustion. Today we have a resource person from IIT Gandhinagar, and his name is Dr. Srisha Bhatt. He holds a PhD in chemistry from University of Lincoln, UK. Having been involved in many science outreach activities in the UK, he found the process of learning and doing science with kids very fulfilling. This paved his return to India with a vision to contribute to the Indian education system. He started with leading weekend science camps in Ahmedabad in low-income schools. He was also selected as one of the 55 RSC teacher developers as part of the Yusuf Hamid Inspirational Science Program to train science teachers in active learning techniques. Currently heads the chemistry content team and is involved in creating engaging and fun chemistry activities. Meanwhile, also focusing on inquiry-based learning. So let us all give a big round of applause for our resource person and let us kickstart this session. Thank you.
Great. Thank you, Justy, for nice. Thank you, Justy, for this introduction. So, I am Shrisha. Hello, everyone. I could see some students here from JNV, Udaipur, and Nagpur. Hello. How are you this evening? Great. So, I think we had a good orientation session by Manish sir, and I hope you have got some document with questions. Have you had an opportunity to go through them? I guess. Just a moment.
Sorry to interrupt you, sir. We are not able to hear your voice properly.
Okay, okay. Let me.
Could you speak a little louder?
Yeah. And now, is it? Am I audible now?
Thank you.
Great, great, great. Okay. Just a moment. I will just ask my colleague if we can see the YouTube comments.
Uh,
We can,
Okay.
but usually YouTube अपन नहीं देख सकते, so they'll see the project. I can see. I'll tell you.
Okay, okay, okay. So my colleague, so it will be an interactive session. So there will be some questions which we are going to ask, and then you can put it down in the chat or in the in the Zoom chat or in the YouTube chat. And probably my colleague Krishna is with me here. There are two more colleagues with me, Nisha and Abhijit, who will do some of the demonstrations for us. So let us quickly start with the session today. So today's session is about candle. So आपने कैंडल तो मतलब जलाए होगा.
Sir, the loudness is not. The loudness is. We are not able to hear you clearly.
Okay, you're not able to hear me clearly. Okay, let me see.
नहीं उनका ही प्रॉब्लम है.
हमारा सही है.
हमारा सही है.
साउंड सही है. हमारे तरफ से सही है. I think from our end it is okay. Maybe something on your end probably. If others can hear me well, maybe they can let me know. Justy, if are you able to hear me?
Shrisha, because I'm using earphones, I'm being able to hear you properly.
Okay,
But
okay.
last time also the same issue was there for people
Okay.
who were on loudspeaker in the class.
Oh,
So
okay.
maybe just check if the mic of the volume is full. And
Yeah.
if it is so, then probably the mic can be brought a little nearer to the mouth.
Okay.
Yeah.
Probably just bring it a little nearer then. Okay. I brought it as close as I can. Okay. Hopefully I will be audible. I will try to keep my voice a little bit higher as well. Right. So you must have observed a candle, right? You must have lit a candle, and you must have seen something happening when you burn a candle, and the process is very fascinating. Like, it looks very simple, the process of burning a candle, but there is a lot of hidden science in it, and that is what we are going to explore. Let me start my PPT. Okay. Okay, I hope you can see the presentation, everyone. Okay, cool.
Yes, visible.
Okay, great. So I will start with a very interesting quote from Michael Faraday from his lecture, which is called The Chemical History of a Candle. There is no more open door by which you can enter into the study of natural philosophy than by considering the physical phenomena of a candle. And this is Michael Faraday giving one of the lectures at Royal Institution in UK. So in UK there is usually this Christmas lectures which they organize every year, wherein scientists come and deliver some lecture or demonstrations to the general public. And this is something Faraday did. Michael Faraday, one of the renowned scientists in the world during that time, who is known for many things, many discoveries, like the world's first motor. So he gave this lecture, and you can see it has been captured here. And the public was so fascinated by all these demonstrations, scientific experiments just with a candle, that he went on to do many more lectures after this, year after year, with the public audience, and always adding more and more experiments. And here you can see this is what they have done is they have they recorded all these lectures into a book, and you can easily find this book on the internet. You just type The Chemical History of a Candle, and you will find many such fascinating experiments. And I urge you to go and download it and then have a look at it. And I bet you will find it very fascinating. So some portions of this lectures we will try to capture in this 1 hour, in this limited 1 hour we have. So let's move on to the first question. What are candles made up of? So if you can see if there are any answers coming, if anyone can answer.
यहाँ पे थोड़ा लेट है YouTube.
So basically
Chat.
Okay, they're saying wax in the chat box. Okay, okay. What is wax made up of? What is wax? And is there any specific kind of wax? So I see 2-3 responses. Okay, so it is indeed wax. Please bear with me. Where do I go for the slide? Wax is product of petroleum. Okay. All waxes are primarily hydrocarbons, whether wax is the animal. Okay, great.
Somebody saying paraffin wax.
Paraffin wax. Okay. So many responses we are having. So they are made from wax, and these are usually paraffin wax, which we get from petroleum. As someone rightly mentioned, there is beeswax, which you get from honeycombs. There is also plant wax, which you usually get from soybean. There's carnauba wax. But mostly what you find in the market, the candles, they are majorly made up of hydrocarbons. Basically paraffin wax, which you get from the petroleum. Okay, I need to go to the front. Okay. As you can see, I am still getting used to this system of all this switching on and off, right, from the PPT to the front. Okay, so candles which you basically see in the market is mostly hydrocarbons, which is paraffin wax, which is usually you get from petroleum products. So usually aapke when you unearth, when you dig and you get all this petroleum products, you then put it in a fractional distillation. You make it go through fractional distillation, and you get these different fractions of the petroleum products, and one of these petroleum products is paraffin wax, which is basically hydrocarbons. Okay. Which are basically hydrocarbons with formula. You can see they are usually hydrocarbons with carbon C20 to C40. They range from C20 to C40 with the formula CnH2n plus 2. So usually, let's say if you have one carbon, then you have probably, let's say for example, you take methane, CH4. But usually paraffin wax, you will find they are like starting from C20 till like C40. Okay, so let's start with some basic, let's start with an interesting experiment. So we say it experiment time. So there are a lot of experiment times we will have in this, and you can also do this after this session. So you have seen that when you blow a candle, right? When you blow a candle, you see the flames are moving a bit, and then they will get extinguished. But I have an interesting experiment where we see what would happen if you blow the candle from the side. So let me go quickly to the front. Okay, that's already front. Okay, cool. So I will take a burnt candle. Okay, I hope everyone is able to see this. I have a candle, and I will, if I blow it from the front, then definitely it will extinguish, right? Okay, but what if I
स्कूल कनेक्ट कर दिया स्कूल कनेक्ट इससे नहीं
Are you able to see it? I'm not sure if I'm able to see. Okay. Okay, maybe now you can. Okay, let me do it from here. So you see where I'm blowing it, the flame will come to this side. If we take another, let's take another one. Okay, I'm not sure if you're able to see. I hope they were able to see. But what happens is when I blow it on the side, the flame turns this way. Right? Are you able to see? And if I blow on the other side, it will move this way. So can anyone tell me why is this happening? If you're blowing on the front, right, it will blow in the direction of the air. But in this case, as we are blowing it, it blows, the flame turns where I'm blowing the air. So if anyone can tell in the chat what is happening. Anyone? Anything on the YouTube? I'm not sure. So it moves in the direction of the flame, and it's very fascinating because if anyone can. Okay, let us see here. I think this is a better angle. Yeah, so Nishaji is here with us, and she is showing where she is blowing the candle on the side, and you see the flame moving towards the direction of where you are blowing. So very fascinating, right? So what is happening? So Nishaji, if you can blow it from the other side. Yeah, if you can. I think we have AC which is on. Yeah. Anyways, so you see this very fascinating thing. So can anyone tell what is happening? What is the phenomena that is happening in this experiment? Okay, so basically what is happening is, I guess you've heard about Bernoulli's principle, right? So whenever you are blowing on this side, right, on one side of the flame, you are increasing the air, right? You are increasing the airflow, and whenever there is an increase in airflow, there is a reduction in pressure, right? So you are having a low pressure area here and a higher pressure area on the other side, and what is happening is the airflow is moving from the high pressure to the low pressure area. That is what is causing the flame to bend. So this is a very fascinating experiment which we used to do, and let's go to the PPT again.
Shrisha, sorry to interrupt.
Yeah.
There is this general comment that we are getting that the audio is very weak.
Okay.
So if it is
Audio is
possible to speak a little louder.
Okay, I will speak a little louder. Okay.
Yeah.
Okay, cool. So basically what we saw, and one person in the Zoom chat has answered Bernoulli's law, and he's correct. So that is happening. Bernoulli's okay. Yeah, Bernoulli's law, wherein you have this high pressure and low pressure areas, because wherever you're blowing the air, the low pressure is getting created, and the flame then turns.
The PPT is visible.
Okay. Okay. PPT is visible?
Now you're visible.
No, I want the PPT.
You want PPT?
Yes.
Then
Okay. Okay, cool. Okay, so we move on to the next question is what burns in the candle? So we have four options here. One is solid wax, one is liquid gas, liquid wax, vapor wax, and wick. So yeah, if anyone can answer it. What burns in the candle? Is it solid wax? Is it liquid wax? Is it vapor wax, or is it a wick which is burning? So you're getting okay, answer, one answer here, vapor wax. Okay, why is it not liquid wax? Okay, cool. So let's explore this through some experiments. Okay, let's explore this. So we have a very interesting experiment. Let's see this. So what we are doing is we have two candles and we are blowing on one candle, and you see it is reigniting, right? So what is happening here? So we take, and here you see that you have this flame, and then you have this some white smoke which is coming, and when you light it, you can see with a candle, you can see it lights again. So what is the fuel here? So fuel here is mostly the vapor wax, as someone correctly mentioned. So we explore this with some more interesting experiments. So what we have done is we have taken a bent tube here and we put it over a flame, and you see there is a white wax which is coming, and when you you ignite it, it ignites. So similarly, we take a straight tube here, and you see it is burning. Right. So what is so here you can see there is some white smoke which is coming. So of course it is the vapor which is coming. So we are clearly seeing there is some vapor which is coming out. It's not the liquid or the solid wax, but the solid wax has converted to liquid wax, and you can see some white smoke which is coming. And when you ignite it, you see the candle. You see the vapor burning at the end of the tube. And very interesting fact is that you put this tube at the middle of the flame. So that is a key thing. I want you to remember this, because we are going to discuss this later on. The tube is kept in the middle part of the tube. Now what we are going to do is we take this tube and put it on the upper part. So can anyone tell me what would happen? Will the same process be repeated? So if anyone can tell me. So just now we have kept the tube. So we have these tubes here, right? So we have used these tubes, bent tubes and a straight tube, and we have kept it in the middle of the flame. But what would happen if we keep on the top of the flame? If anyone can answer in the chat. So we have some answers here. So I'm seeing currently vapor wax, wick, solid wax. Okay. Interesting. So let's see what happens when I'm not getting many responses. So let's just see what happens when we go towards the upper part of the flame. So let's say I have taken this tube on the upper part, and you see some black smoke which is coming. Earlier you saw some white smoke which is coming, and now you see some black smoke. And will it burn? So that is the question. So let's see what happens. So here we are trying a tube. We are taking a tube. Sorry. Okay, PPT video is not good. Oh, okay. Okay, I will have to play again. I think the from where did we not see the PPT? I think this one. Okay. So here you see we have kept this tube on the top part of the flame, and you see there is some black smoke which is coming, and let's see if this black smoke burns. So we take this, and we try to ignite it, but it won't burn. So what are these distinct regions? So then we come to the the flame. So you see there are two distinct regions which we saw. We put the tube in the middle, and we put the tube in the on the top of the flame. So I think you must have seen, like let's say whenever you burn your gas stoves, right? आप अपना gas stove जलाते हैं तो आप कौन सा color देखते हैं उसमें? You see some blues, right? Whenever let's say you burn some wood, and you see some yellow colors. So what are these distinct colors which are rising from this process of burning the candle? So that is what we will see. Okay. So you see there is a blue region at the bottom. So whenever we see, let's see, let's go towards. So whenever we use our, we burn our gas stoves in our home, we see there is a blue flame which is coming out. But do you observe any smoke which comes? Anyone in the chat? Do you observe any smoke which comes when you burn your gas stove? No. Okay, you see mostly some blue flame, right? So blue flame is where you have a complete combustion. Okay, this is the one. So blue flame is where you have a complete combustion of the paraffin wax, and you see this blue color here. And so here you can see this image, this diagram. This is the blue region. Right, so where the vaporized wax and oxygen burns completely to produce carbon dioxide and water, and above that region is the gray yellow region where we have kept the tube first, where you see this vapor wax coming. So this is where an incomplete combustion of wax in the form of a vapor is happening, right? So there is an incomplete combustion, so there is some unutilized wax vapor which is there. So whenever we keep the tube in this region, in the middle region, you will see some white fumes which are coming out, the white smoke, which is majorly the fuel, which is the vapor wax. And that is how when you try to bring a match near it, burning match near it, it burns. But whenever you go above, so when you go in the top region, you see this is a yellow region, right? So this is the yellow region wherein the wax vapor has been swept away. So there is no wax in this region. So there is just the carbon particles which have been produced from the incomplete combustion. So you see the complete combustion is just happening in this region, right? And the incomplete combustion is happening in this region, and there are some carbon particles which have been produced, which reaches the top. And you can see this when these carbon particles burn, they produce this yellow color, and we call this incandescence process. And another fascinating thing, have you ever thought why is the flame of this shape, like a teardrop? If anyone can tell me in the chat, why do you see the flame as this particular shape, as a teardrop? What is the reason? Anyone in the chat? Okay, I think some part of it was already in the slide. So here you see the oxygen. The oxygen from the air is diffuses from the base. So whenever you burn, so what would happen is here the wax is converting into a liquid because of the heat, and you have this liquid wax which crawls up. So have you seen like let's say you put some cloth in the water. Let's say you put some cloth in the water and you see water rising up, right? What is this process called? Does anyone can anyone put it in the chat? What is this process called? क्या बोलते हैं हम इसे? जैसे कुछ भी हमने क्लॉथ डाल दिया पानी में और पानी ऊपर राइज कर रहा है. It's also a process how trees, wherever like you water the plants at the root, but how does the water rise up? So that is also capillary action. Yes. So I am getting some answers. Hot gas is lifted up, which carries the flame as well. Right. There is a buoyancy. There is capillary action. Yes. Yes. All correct. Let's move to the. Oops. Okay. I think we are there, right? I may not have changed to the PPT.
Chrome.
Right. Okay. So here you see the liquefied wax, it crawls up the wick by capillary action, and you have this liquefied wax which is turned into vapor form, as we saw in our previous experiments, and oxygen which has been from the air, it diffuses here and it travels up. So you have a buoyancy which is there, because as the gases go up, there is it's a more hotter region, right? So there is this thing where you see there is a convection current which is going, and you see the shape because of this. But what would happen if we don't have any gravity? Can anyone tell me what would happen if we don't have gravity? In the chat, anyone from the schools, if they want to put it. So there is a very interesting okay, so there is a very interesting image which we have from NASA. Okay, am I not able to? Listen? Okay. So there is a very interesting image, as you see on the right hand side, where you see the flame is very different. It's like round, almost spherical, and not like this teardrop shape. So why is the reason what is the reason for that? If anyone can put it in the chat. Yes, someone has put the flame bends down. Okay, so basically what is happening is, because you don't have gravity, so you don't have all this convection current from the air which is flowing up. So you basically have you just have a spherical shape. You don't get this tear shape because there is no gravity. Yeah. Okay, that's fine. Okay, so we have another image here where we see, again the capillary action, the liquid fuel which is going up, and there is a vaporized fuel, and there is a heat which is rising up. Okay, so this was all about the flames. Now let's move on to one of our experiments where it's again now our experiment time. So we will do some very popular experiment. I am sure you must have done it, where you put a glass over a burnt candle and you see something happening. So let's see that. So we have
Stop video.
If you can highlight spotlight, yes. Okay, so we have Nisha ji with us, who is doing this experiment. And we have a candle which is burning, and we have some water. And let's see what happens. So I want you to observe a few things, okay? The flame has died. And okay, there is something which is happening on the glass. If Nisha ji, you can just move a bit with the black background. Okay, maybe not. Okay, so what's happening here? Can anyone tell me? So you see some condensation on the glass. Can you see the condensation on the glass? There is some condensation, right? There is some vapor which is there. So what is this vapor? Can anyone tell in the chat?
The absence of oxygen.
Yes.
The absence of oxygen.
Okay, absence of oxygen. Okay. Just a minute. If you can, it's not clear. Okay. Yeah. If you can show the glass. Yeah. A little bit lower. Little bit lower and focus. Okay. Acha. So there is some condensation which is happening. So what is this? Is it vapor wax or what is it happening? So we see the burning of the candle. We see the candle extinguishes. So what happens when a candle burns? What reaction is happening? If anyone can put. Someone has put vaporized wax is condensed to solid wax. Okay, very interesting. Someone has put that vaporized wax is condensed to solid wax. So if we can go again and do it, yeah. If we can show them what is it inside. Who else agrees? If you can raise up your hands. Who else agrees that vaporized wax is condensed to solid wax? I don't see any hand raising. Okay, they're not agreeing with this. So what else is there then? Yeah. Please do it. Okay, you see the candle flame extinguishing, right? And you see some water which is rising, and immediately you see some condensation, right? So if we can if we can get it to me, probably that would be best. Okay, let's see if we have Abhijit on the camera, if we can focus this. Yeah, okay. Now what I want you to do is, if you can remove it and just feel it with the fingers. If you can get it to me, probably that would be great. Okay, I have this. I'm not sure if. Okay. Okay, my video was off. Okay. It's on. Okay. I don't know. I think it's best to show it there only, probably. I don't think it's visible. So okay, so let me just put my finger. So you can do this yourself, right? So just now I'm doing it and I see it's not wax. It's definitely not wax, but it's something else. So what it could be? What are the products of combustion? So as we saw, we are talking about candle and combustion. So what is the reaction of combustion? So you have some oxygen which is combining with the fuel. What are the products? If anyone can tell in the chat. Okay, let me show you the reaction which is happening, which is oxygen from the air is combining with the hydrocarbon, and it is producing carbon dioxide and water. So the water vapor is what you are seeing, which is condensing on the glass. So you have two molecules of oxygen reacting with the hydrocarbon and producing two molecules of water, and that is what you're seeing. And why does the flame extinguish? Why does the flame extinguish? If anyone can answer. Why does the flame extinguish? In this experiment, we saw that the water is condensing, but then you also see the flame extinguishing. So what is happening here? If anyone can answer. Depletion of oxygen. So before that, I got some answers: carbon dioxide and water, which is correct. Depletion of oxygen, I am getting the answer that oxygen is getting consumed, right? So that is because oxygen is getting totally consumed. If everyone agrees to that, please raise your hands. Yes, I see some hands raising. Oxygen is getting totally consumed, and right. So you have some presence of CO2, okay, which is forming as a result of the combustion. Okay. Let's see. Let's explore through some experiments if that is really the reason. Okay. Let's go to our PPT. Okay. But one more thing I want you to do is, how would you find out the amount of oxygen which is being consumed? So there is this is one of your homework. So you have to find out is if all the oxygen is being consumed. So what you need to do is, let me go to my front. So what you need to do is, you take candle, right? You take one candle and you measure it on a weighing scale, and you note down the weight and you burn it. You perform this experiment, and it gets extinguished, and then again you take the weight of that candle. Okay, and whatever weight you get, I want you to find out from that weight, using this formula, how much oxygen is getting consumed. So I think I need to change to Chrome. Okay, okay. So that is your homework, and that will be there in the question which you will get. So okay, this is the combustion, but we got many answers that total oxygen is getting consumed, and we also have this notion that there is a water rise, and that water rise is because all the oxygen is consumed. There is a vacuum which is being generated. Okay, so what I want you to, if we can do the 2 candle experiment. So what we will do is, we will take 2 candles of different heights this time. Earlier we had taken 1 candle, and we saw that there is a little bit of rise of water. Let me go to the Zoom. Okay, we already have the system ready. Nisha ji is there, and there is some yellow water which is some food color which we have used, not to say yellow something which we usually say. Okay, Nisha ji, if you can put the glass over the candle, and you see the top candle is extinguished, then the bottom candle is extinguished, and you see some rise in water. So this is definitely, if you see, the level of the water is more than what you observed before, right? And also you saw that the candle the water rise happened after the candle extinguished. Okay, let me go to the PPT. So this is you saw. Okay, now let's say I have 3 candles. We have here, so in the video you see there are 3 candles here. There is 2 candles in the center, and there is 1 candle here. Okay, so let's see what happens. So you see the left one extinguished first, then the 2 candles set up extinguished, and then you have this 1 candle which is still burning, and now it has. So if you see, once it is extinguished, then only the water rises. If all the oxygen was consumed, then as the oxygen is being consumed, the water should have risen, but you don't see that happening. You see this third one, still the water has not risen. Once it extinguishes, then you see some water rising. So the fact that all the oxygen is getting consumed might not be entirely true. So let's see this one more experiment which was done by a scientist, and what he has done is, he has हाँ, तो उनके पास क्या है, एक कैंडल है एंड एक ग्लास जार है, एंड देयर इज अ रैट और अ माउस यू कुड से, एंड इट इज currently moving. Let's say if all the oxygen is being consumed, then would the rat survive? Let's see what's happening. So the candle is getting extinguished, और आप देख रहे हैं चूहा अभी भी मस्त है. तो चूहे को हमने नाम दिया है टाइगर, और आप देख सकते हैं कि टाइगर अभी भी जिंदा है. This is tiger still I mean, it's a closed system, and you can still see the rat, the mouse which is our tiger, is moving very actively. It's still almost 20 seconds. And अगर हम और उसको आगे ले जाए, वो और भी active है. He is doing some cleaning of his teeth. He is roaming around. He is very active, right? So the notion that all the oxygen is being consumed is not true. And as we also see, and we also saw that the water rise which is happening, if all the oxygen is being consumed, so let's say the combustion is happening, the oxygen is being consumed, right, then the water rise should have been gradual. It wouldn't have been like at the same time. But it happens, what happens is, it is doing that. And also one more interesting aspect is, what we saw is, we saw two candles, right? And we saw two candles, and the top one extinguishes first, whereas the bottom one extinguishes later. And so what is happening in that? If anyone can put it in the chat, if they can tell what is happening. What is happening there, where you have two candles of different heights, and you put a glass jar, and you see the top one is extinguishing first, and the bottom one is extinguishing later. If anyone can put in the chat, two candles presence is using more oxygen. Okay. So that is for for the water rise. I think someone is suggesting 2 candles, but is it really because of the oxygen? So that is what we are trying to experiment and get a conclusion, that why is the water rising? Is it because of the complete depletion of oxygen? But we saw that oxygen is not getting completely consumed. If it was the case, then the tiger, अपना जो tiger है, rat, wouldn't have survived that. And plus we saw that we have 2 candles, and still we see the water rising higher when you have this oxygen. When you have this 2 candles set up, oxygen is heavy. Okay, how is oxygen heavy? Yes.
Excuse me, sir.
Yes.
टाइगर क्यों नहीं मरा?
हाँ, वही बहुत important सवाल है कि टाइगर मरा क्यों नहीं? So that is the thing, like we think that जो टाइगर है तो वहाँ पे पूरा ऑक्सीजन कंज्यूम हो गया है, पर पूरा ऑक्सीजन कंज्यूम नहीं हुआ है, और टाइगर तभी भी जिंदा था क्योंकि there is some production of carbon dioxide, right? But if carbon dioxide, can anyone tell me what is the molecular weight of carbon dioxide? Molecular weight of carbon dioxide or molecular weight of oxygen? कौन सा heavy है? Oxygen is heavy, people are saying. Why is oxygen heavy? Carbon dioxide is, oxygen is 16 and carbon dioxide is C plus C add हो गया ना वहाँ पे. Is it 44? Okay, what is 44? Okay, so which one is heavier? Carbon dioxide? Everyone agrees? Carbon dioxide is heavier? So carbon dioxide को तो नीचे आ जाना चाहिए था. तो वैसे देखे जाए तो 2 एक्सपेरिमेंट है हमारे पास कि जिसमें हमने देखा कि बड़ा और छोटा कैंडल है, तो छोटा कैंडल पहले एक्सटिंग्विश हो जाना चाहिए था अगर कार्बन डाइऑक्साइड हैवी है और वो नीचे जा रहा है. और इवन टाइगर के केस में अगर मान लीजिए कंबस्शन हुआ, थोड़ा भी ऑक्सीजन कंज्यूम हुआ और कार्बन डाइऑक्साइड प्रोड्यूस हुआ, तो हैवी है तो नीचे जाना चाहिए था, तो वो तो आई मीन ही शुड हैव डाइड बिकॉज देयर वाज ऑक्सीजन विच इज़ गॉन डाउन. व्हाई इज इट हैपनिंग? Okay, let me give you a hint. So you are burning something. So what would be the temperature? Would it be high or would it be low? So near the flame we see that the temperature increases. What happens to a gas when the temperature increases? What happens to the volume of the gas? What happens to the density of the gas? Can anyone tell? In the chat? What happens if you increase the temperature of a gas? What happens to the volume? कोई जवाब नहीं दे रहा है. Will it increase or will it decrease? Increases. Gas is lifted up and expands. Increases. Okay. Everyone is saying volume increases. What happens to the density of a gas when the volume increases? Density is mass by volume. सो इन्वर्सली रिलेशन हुआ ना, वॉल्यूम बढ़ा तो क्या हुआ, डेंसिटी घटा, अगर डेंसिटी घटा तो क्या हुआ, it will be lighter, right? So it will rise up. So that's why you see the carbon dioxide has gone up and the oxygen is a little bit below, because the carbon dioxide was produced with the consumption of oxygen, और गर्म है इसलिए वो ऊपर रह रहा है, इसलिए जो बड़ा वाला कैंडल है वो बुझ गया. Similarly, in case of tiger, what we see is the carbon dioxide stays up, it doesn't reach where tiger is, right? So even there is one interesting incident where in Surat there was this coaching center where वहाँ पे आग लगी थी, और वहाँ पे यूजुअली ऐसे केसेस में क्या होता है कि कार्बन डाइऑक्साइड ऊपर रहता है. सो यूजुअली व्हाट यू नीड टू डू इज यू नीड टू क्राउल, you need to get down to the floor and crawl, because if you stand up the carbon dioxide will be above, or probably you will asphyxiate, you won't get enough oxygen. But if you crawl and if you, whenever such incident happens, you need to crawl and you go, then you might survive. So that is the reasoning what is happening कि टाइगर जिंदा क्यों रहा. एक तो यह है कि पूरा ऑक्सीजन कंज्यूम नहीं हुआ है, एंड वी सी दैट, राइट, पूरा ऑक्सीजन, एक मिनट, हाँ, वी डोंट सी दैट हैपनिंग, राइट. सो वी सी विद टाइगर, and so how do we prove? But we are just saying now, right, we are just assuming, I mean we are deducing from our knowledge about all this density and what happens when a gas, what happens to a gas when it increases, when the temperature increases. But how do we prove it? How do we prove by experimentation? If someone can think and tell what we could do to experiment and say कि अच्छा ये कार्बन डाइऑक्साइड ऊपर ज़्यादा है और और ऑक्सीजन नीचे है, तो how would you do it if anyone can tell? I want you to think about all these experimentations, because you have some hypothesis with you. So there are various hypotheses which we are having currently. ऑक्सीजन पूरा कंज्यूम हो गया, कार्बन डाइऑक्साइड बन रहा है पर ऊपर है, पर उसको प्रूव कैसे करें? How do we prove it? So let me show you some of the experiments which we have done. Let me go to Chrome. Let me go to the PPT. Okay, not a PPT. Okay, ठीक है. So what we have done is, so we have the system where हमने ये PPT select कर लिया था मैंने. I hope everyone is seeing PPT. Yeah. Okay. So what we have done is we have taken this system जहाँ पे हमने एक डंडे पे ये 4 वो टैबलेट के जो स्ट्रिप्स होते हैं खाली हैं, वो हमने ऐसे लगा दिए हैं, and we have put some cresol red indicator. So cresol red changes from red to yellow in presence of carbon dioxide. So what we have done is we have lit a candle and we have closed it with a container, and then we see some changes which is happening. So this is after different times which you are seeing. So you see it is pinkish red before, right, you see, but as you go on you see there is some yellowish which is turning yellow. So you see this is also turning yellow, but comparatively if you see this thing, this is turned yellow, but this is a little bit pinkish yet. So you see this happening where you see this top part turning yellow first rather than the below part. Similarly, you can use some sensors like carbon dioxide and oxygen sensors in the different regions, and then you can observe where it is higher, where the carbon dioxide concentration is higher, where oxygen concentration is higher. So this is what very recently in 2020 some of the researchers did this study where they observed the changes in the CO2 concentration and the heat, and they found that the CO2 concentration is higher in the top part rather than the lower part, and they observe it in real time through these sensors, and that is what they deduced, that because of the density of oxygen depends on the temperature, you will find it more higher. But can you tell me, so यहाँ पे हमने तो क्रेसोल रेड यूज़ किया था, पर क्या और ऐसे क्या केमिकल है जो हम यूज़ कर सकते हैं जिससे हमें कार्बन डाइऑक्साइड का चेंज पता चल जाता है? आई थिंक वेरी कॉमनली डन, but if anyone can put in the chat, if anyone knows what else you can do? Very easily available. What would you use instead of? So I have used cresol red, which is an indicator, which changes its structure in presence of carbon dioxide, changes from red to yellow. But what else is there? If anyone can answer. ये आपको पान के शॉप में मिल जाता है. पान के शॉप में यूजुअली आप पान पे लगाते हैं. एक सफ़ेद सी चीज़ होती है. क्या है? Lime water. Yes, someone has said pass it through lime water. Yes. So instead of cresol red, you make the system and you put some clear lime water, right, on all this 4 heights. You cover it and then you see the change, right? So I want you to do this yourself. You don't need much, right? You just need a candle, you need this setup where you do this, and you need some lime water जो आपको easily मिल जाएगा. तो आप देखिए कि कहाँ पे कौन सा कलर, कौन सा रीजन पहले वाइट हो रहा है. Usually what happens, you have clear solution, but when carbon dioxide is dissolved in lime water, then it turns milky. Yes, someone has said calcium hydroxide. That is correct. Calcium hydroxide is what it is. Okay. Let me go to the PPT. Okay, I'm having some problem.
क्या करना है?
PPT. Okay, as you can see, I've still not mastered this. Right. Okay. So we saw that what is happening with carbon dioxide and oxygen, but the question comes: why does the water rise in this experiment? So many people said all the oxygen is being consumed, which leaves a vacuum, right? So, but we see that all the oxygen is not consumed, and so definitely it is not because of the oxygen which is being consumed. We see this water rise. Another thing we saw is water condenses on the glass, but how much of the water is being produced and how much of the oxygen? So again, I want you to go back. I will put it in the document which you will receive, where we have the questions for your homework, where you have to calculate the amount of oxygen which is being utilized and how much of water is being produced. So is that water condensation so much, or is the combustion has produced so much water that it leaves a vacuum for the water to rise? So I want you to do that exercise. And one more thing, let's say we don't have a candle and we just heat it. We remove the combustion process. And we just have our we just have a glass, and we have this, we heat it up and we put it, and we see some water rise. So we don't have any candle, so no oxygen is being consumed, no carbon dioxide is being produced, but still you see a water rise. So then what would you say is the reason? If anyone can say, we don't have a candle here, we don't see any combustion happening, we are just heating the glass and we see a water rise. So what could be the reason? So in the same, in the candle, we see some water rising. If someone can put in the chat, what could be the reason here? Yes, anyone? I see, I think students are still thinking what is happening. Should I show it again, or is it fine? So we saw, okay, let me show it again. Okay, there are some hands being raised. Okay, let me go to the PPT. And this one. Oh, sorry. Okay. So another is, there is some expansion of the gas which is happening, right? So you have some hot air. So when you did this experiment wherein you are heating this glass, so what is happening to the air around it? It is getting heated, right? So there is a volume expansion, and when you put it in water, it cools down. it cools down, and then you see the water rising. So what is happening? There is an expansion of the gas, of the volume of the gas due to heat, and eventual contraction, which then leads to the water to rise. So currently, from these experiments, whatever hypothesis we have generated, so this one experiment definitely leads to this, but is it really it? Unless and until you do some more experiments to find out if if really this is the reason, the questions will still remain. So currently, till now, we have this thing. We have this result wherein we say that okay, the expansion of the volume of the gas is happening not because of the oxygen which is being consumed, right? So this is the reason. Also, many people have done this with a closed system. So what happens is many people say that our system is not completely closed, wherein there is some air which is escaping. You see some bubbles, wherein we didn't see any bubbles which is coming out when we put the glass. But many people have said that okay, what you're doing is not correct. You need a closed system. So in a closed system, you put this jar, measuring cylinder inside this water. You take some water out, and then you have this system here. And then when you you ignite it using so there is artificial wick which is here, and you use some external power supply, and you heat it, and it burns. So this is what we are trying to do currently. Okay, so this was about our experiment, water rise experiment. Okay, but the question now comes is, we took a closed system, right? So we took a beaker or a glass which was closed. But what would happen if you take an open tube? So here we saw that the candle was extinguished. Okay, some of the oxygen was being consumed. There is some carbon dioxide which is in the vicinity, and that leads to the flame, extinguishing of the flame. So it's not just the entirety of the oxygen which is being consumed. It is just a little bit of oxygen which was consumed. So there is a local depletion near the flame of the oxygen, and the carbon dioxide which is produced, which comes, and it is a mixture of these things which leads to its extinguishment. But what would happen if you take an open tube? That was a closed system, but what would happen if you take an open tube? Anyone in the chat? Will it, I think if it is an open tube, it should keep on, right? It should keep on burning, I think. What do you say? Let us see. Okay, let us see if it's really the case. Okay. This one, right? Okay. I finally learned how to do it. Okay, so let's take an open tube. So you see here that both the tubes are open. I mean, both the ends are open, and you put it. Okay, you put it on the candle, and let's see what happens. It should keep on burning, right? I don't know if anyone has answered, but you see it has extinguished. So what is happening here then? Even if you take an open tube, you find this happening. What could be the reason? Okay, let's do one more experiment. So I will just show you the tube. So you can easily make this tube using this OHP sheets or lamination sheets you have, and you just roll it, and you can make these tubes of different height. So you take a candle, and then you can make this and do this experiment yourself. And what we have done here, let's see, we have taken another tube, and we have reduced the height a little bit. But before that, I would just want to check if anyone has answered. Depletion, it continues until depletion of oxygen. Depletion of oxygen. Okay. Now let's see what happens if we take a tube of a little bit less height. What do you think will happen? We see this, it's almost it's extinguished, right? But no, जैसे टाइगर जिंदा था वैसे ये फ्लेम भी जिंदा है. So you see कि flame almost getting extinguished, but again it is burning again. So what is causing this? What is causing this? I want you to think and think around it. What is happening here? And let's say I take one, I change the height again. So this time I have taken a smaller tube. This time I have taken an even smaller tube, as you can see. And यहाँ पे कुछ होता है क्या? We don't see any change in the patterns, right? We are just seeing it burning. Okay, so we saw it is still burning. So what is with the height of the tube that this three different processes are happening? One in which the candle is getting extinguished. One in which you see there is some oscillation, right? You see some flame which is almost dying, but then it's trying to rejuvenate itself. So very interesting. So someone is saying at heights oxygen level decreases. Okay. Let's go again to this. So I just want you to show this because we find it very fascinating. So we keep on repeating this, wherein the flame just keeps on oscillating. It almost dies off, and then it gets itself. So I want you to do this and think around what is happening. So I will not give you the answer what is happening, but I will show you one more experiment, and from that maybe you can get some idea. So in this case, what we do is we have a partition like a cardboard strip, and you cut it according to the tube size, a T-shaped cardboard tube. So let me show. So if you can see here, it's a T-shaped. If you can see here, it's a T-shaped strip which is cut according to the diameter of the tube. Okay, and I put it, and this is the same height where the candle extinguishes. Okay, so I have put this, and we see that the candle is still burning. So what I have done is I have used something, some agarbatti, and on one side you see the smoke is rising up, right? Do observe what happens here. You don't see any smoke which is rising on one side. On one side you see the smoke is rising, but on the other side you don't see. So usually you find this pattern here. And similarly what we have done is, so here maybe you can see it more clearly. On the left hand side you see the smoke is rising up. Here the smoke is going down. And we tried to observe what is happening. So one side, what happens when you put a partition, it is being divided, wherein the hot air rises on one side and the cooler air, the fresh air is going inside, and that is what is causing this flame to sustain, and you don't see it extinguishing. Okay, and we did some IR experiment. So we took an IR camera and we see, so this is the partition, and on one side you see the red region, right? So red is where it is more hot. So you see that the red part is just on one part, and here you see yellow, a bit blue. So that is the cooler part. So that is where the air is entering, and this is where the hot air is going out, and you see it is getting this fresh breath of air for the flame to sustain. So what is happening? If anyone can put in the chat, we see. So in our case where we didn't have a partition, right? What is happening there? Why the flame is able to flicker or sustain? And with this experiment, with the T-shaped partition which we did, we saw that it is getting that it is getting the fresh air which is coming in, and it's able to sustain. There is this convection currents. I think I almost gave away the answer, but there is you will find this hot air coming in and the cold air. Hot air going out and cold air coming in. So I want you to think around what is happening if we didn't have a partition, and you see this oscillation of the flame, right? You see वो बुझ रहा है और फिर जल रहा है, बुझ रहा है जल रहा है. So what is happening there? So I want you to think around it, and we will give you this question, and please think, and you can also do this, all these experiments yourself, and let us know, because you see this experiment was first conducted in 1800, right? In 1800 से लोग करते आ रहे हैं और अभी तक सबको पता नहीं है कि क्या हो रहा है एग्जैक्टली, राइट? 2020 में रिसर्च कर रहे हैं कि अच्छा ये ऊपर वाला कैंडल क्यों बुझ रहा है, नीचे वाला बाद में क्यों बुझ रहा है. सो ऑल दिस वेरी रिसेंटली, आई मीन there has been not much research which has happened in this, and there is an opportunity for you to conduct these experiments yourself, with just candle and just with a few things, and try to find out what is happening, right? We did one more experiment where we took 3 candles of different heights, and there we see a reverse result. There we see that the bigger candle is extinguishing the last, राइट? जहाँ पे अगर हम बोल रहे हैं कि कार्बन डाइऑक्साइड ऊपर है और वो एक्सटिंग्विश हो रहा है, तो 3 कैंडल आप लीजिए, एक बड़ा, एक उससे छोटा और सबसे छोटा, एंड देन यू पुट द glass, and then you see which one extinguishes last. So again, that is what you need to do. Again, we will put in the question. You need to do that and observe what is happening, and then think around what is happening. ये क्यों हो रहा है? You form an hypothesis, and then you conduct some more experiments until you reach a conclusion. That is what the scientific process is, and that is what we have been trying to do with this experiments. How we have some hypothesis, and how we will try to investigate each hypothesis through some experiments. So you do this process and you reach some conclusion. I think that is good enough for now. I don't know if the time is up. But yeah, if anyone has any questions, then please they can put in the chat. I don't know, Justy, if we have time.
If any of the students have any question, we can take it right now. We have like 1 to 2 minutes for that.
Okay.
Yeah. Students, any questions? None, I suppose. Yes. So yeah, thank you so much. I think we'll conclude the session now.
Okay.
Yeah.
I hope I have not bored all of you with with some of these things. I hope it was interesting, and it's even more interesting when you do it yourself and observe this. We tried our best to show it, make it into videos and then show it, and hope it was
I think
some
it was an
questions
amazing session. What do you guys think? Students, you can unmute yourself and tell. All right, okay. I think it was a good session. A lot of myths around the science that we thought, was sort of busted, and quite many scientific investigation curiosity, I think, was kindled today by this session. Thank you so much, the entire team of IIT Gandhinagar, and especially to you, Dr. Srisha. All right, then we all will meet in the next session now, which about which it will be soon notified to you all. Till then, bye bye. Take care. Keep questioning. Keep being curious.
Ma'am,
Yes,
ma'am, we have to appear the test right now only.
you
No,
can do it anytime.
Okay, ma'am. Thank you, ma'am.
yeah.
All right.
Okay.
Okay then. Bye bye. Take care,
Bye.
everybody.
Bye everyone. Stop it.